Hello, welcome again. We are solving some questions of heat transfer. The topic is modes of heat transfer. Question number 8 is assertion A. Uh, Non-metals are having higher thermal conductivity than metals. Reason: free electrons in metals are higher than those of non-metals. Option A, both A and R are individually true and R is correct explanation of A. Option B, both A and R are individually true but R is not correct explanation of A. Option C, A is true but R is false. Option D, A is false but R is true. So, uh, so metals have higher conductivity than non-metals due to free electrons, and but here in this A it is given that non-metals have higher conductivity as compared to metals, so that is wrong, and this is right because free electrons in metals are higher as compared to non-metals. That is correct. So answer is B. Next, question number 9. Assertion A: heat transfer at high temperature is dominated by radiation rather than convection. Reason: radiation depends on fourth power of temperature while the convection depends on unit power relationship. Option A, both A and R individually true and R is correct explanation of A. Option B, both A and R are true but R is not correct explanation of A. Option C, A is true but R is false. Option D, A is false but R is true. So heat transfer at a higher temperature is dominated by radiation rather than convection. Okay, that is correct, and this is due to the fourth power of temperature involved in radiation. So radiation heat transfer is sigma 8 T14 minus T24. So that is the radiation heat transfer, and that is the convection heat transfer. And as this is the fourth power of the temperature, so uh, this fact will be this factor will be more when the temperatures are higher. So answer is option A. 9 answer is A. Next, question number 10. A steel ball of mass 1 kg and specific heat zero point 0.4 kilojoule per kilogram is at temperature of 60 degrees Celsius. It is dropped into 1 kilogram water at 20 degrees Celsius. The final steady state temperature of water is option A 23.5 degrees Celsius, option B 30 degrees Celsius, option C 35 degrees Celsius, or option D 40 degrees Celsius. So steel ball temperature is mass of steel ball is 1 kg and initial temperature of the ball is 60 degrees. Specific heat is zero point 0.4 and initial temperature of water is 20 degrees Celsius. So if T is the temperature of the ball after after the equilibrium is attained, and T is the temperature of water also. Okay, and specific heat of water is 4.8. So then heat lost by ball will be equal to heat gained by water. So heat lost by ball is 1 into 0.4 60 minus T, and heat gained by water is 1 into 4.18 into T minus 1. So that is the final temperature of the water, and this is the also the final temperature of ball. Okay, heat will be lost from the ball and it will be gained from the water. So it will be gained by the water and it will be lost by the ball. So equating the two, we can get T as 23.5 degrees Celsius. Okay. Next, question number 11. A 2 kilowatt 40 liter water heater is switched on for 20 minutes. The heat capacity Cp for water is 4.2 kilojoule per kilogram per degree Kelvin. Assuming all electrical energy has gone into heating the water, increase of water temperature in degrees centigrade is option A 2.7, option B 4, option C 14.3, option D 25.5. So as the 1 liter of water is your 1000 centimeter cube of water. Okay, 1 liter is 1000 centimeter cube, or in terms of meter it is 1000 by 100 cube. Okay, and as density is 1000, so we can find out the mass of the water of 1 liter of water. So that is 1 kilogram of water. So performing these calculations, we can find out relationship between 1 liter of water and 1 kilogram of water. So as there is 40 liter of water, so there is 40 kilogram of water. Okay. So heat supplied by heater is in continuous, and wattage of heater is 2 kilowatt, and it is switched on for 20 minutes. So 20 minutes means 20 into 60 seconds, and this is a 2 kilowatt. So 20 into 60 into 2000, that is 224000 joule. So heat supplied by water, or heat supplied by heater, and this heat is gained by water, as there is 40 liter of water, and this is specific heat is 4.2. So if you multiply by 1000, and this to delta T, temperature change in temperature, so then equating these two, heat supplied by heater and heat gained by water, equating these two, we can find out delta T. So delta T is 14.3 degree Celsius. So answer is option C. Question number 11, option C, 4 and 1. Next, a 100-watt electric bulb was switched on in a 2.5 meter into 3 meter into 3 meter size thermally insulated room having a temperature of 20 degrees Celsius. The room temperature at the end of 24 hours will be option A 321 degrees Celsius, option B 341 degrees Celsius, option C 450 degrees Celsius, and option D 470 degrees Celsius. Okay, so 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 here here the watt of bulb, the power of bulb is 100 watt. It means it is supplying 100 joules of heat in 1 second. Okay, so it may so in 24 hours it will supply 100 into 24 into 60 into 60, the amount of heat. Okay, as the room is insulated, so it will heat the room, and we can assume a constant volume process, because volume of the room will not change, and we can take the density there as 1.2. Okay, approximately 1.2, it is like that. And volume of room is 3 into 3 into 2.5, and CV for air is here 718, and let T be the final temperature, then your T will be here, equating the two, T will be here 465.7 degrees Celsius, or say 470 degrees Celsius. Okay. Next, question number 13. Hot water flows with a velocity of 0.1 meter per second in a 100 meter long and 0.1 meter diameter pipe. Heat loss from the pipe outer wall is uniform and equal to 420 watt per meter square. If the inlet water temperature is 20 degrees Celsius, neglect effect of pipe wall thickness, Cp water is 4.2 kilojoules per kilogram per degree Celsius, density of water is 1000 kilogram per meter cube. Temperature of water at exit is option A 72 degrees Celsius, option B 76 degrees Celsius, option C 78 degrees Celsius, and option D 74 degrees Celsius. So mass flow rate of water m is rho into area into velocity. Okay, so rho of water is 1000 and diameter is 0.1 meter, and B is 0.1 meter per second. So mass is coming out as this is a kilogram per second. Okay, kilogram per second, 0.78454 kilogram per second, and surface area of pipe is this 31.5 from using pi d, 31.416 meter square, and heat loss per unit area is given as 420, so heat loss is your multiply by this, so that is 139,194 watt, and equating this heat loss by the mass by the pipe and heat supplied, we can find out temperature as 70 degrees Celsius.